So in 5.7, we're going to work with complex zeros and the fundamental theorem of algebra. So complex zeros mean we're not talking about just real numbers now. We're also talking about imaginary solutions as well. So the first question, information is given about the polynomial f of x, whose coefficients are real numbers. Find the remaining zeros of the function. So the degree is 3. Again, based on the fundamental theorem of algebra, the degree tells you how many zeros there will be, real or imaginary altogether. So if the degree is 3, that means there's going to be 3 zeros. They all could be real, or they all could be complex, or they could be a mixture of real and complex. So one thing we pick up on is when it comes to complex zeros, if a plus bi is a 0, then a minus bi is a 0. So when it comes to complex zeros, they always have to occur in pairs. So if there's 1, there must be 2. So notice how we have -1. Notice how there's a 5 minus I. That means there's also got to be its conjugate, which is going to be 5 plus I. So the missing 0 would be 5 plus I. So -1, 5 minus I, and then 5 plus I would be the third 0. So again, if we have one complex 0, its conjugate must exist. So if I gave you, like I said, 2 plus 3i, then 2 minus 3i would have to exist. Or if I gave you 5 minus I, then the 5 plus I has to exist. That's what we mean by conjugate. So notice how the real number part does not change sign. It's the imaginary part that changes signs. So notice how the 5 stayed put, but that minus I turned into a plus I. That's how we create the conjugate. So that would be the remaining 0. So now we have 3 zeros, 1 real and 2 complex.